In this lesson, we are going to talk about the transformation of the base function y equal x squared by introducing a new parameter h. In the previous lesson, we talked about the parameters a and k. Now we are going to talk about what will happen if this parameter changes. Before I go through and start talking about h, let's just refresh our memory that the a value or the a parameter is going to decide if the base function, the graph, is going to be compressed or stretched vertically, and if a is negative, is going to be reflected upon the x-axis. Just to show you what exactly we mean is that if I turn on the graph of y equal a times x minus h squared, you can see that the color of the graph becomes black, which is on top of y equal x squared, because a is 1 and h is 0. Now, if I change a to a positive number, let's say I change it to 3, you can see that the graph of the base function y equal x squared is stretched vertically or compressed horizontally. If I increment a more, you can see that the stretch is bigger and the compression is also more. Now, if I change the value of a to a number between 0 and 1, let's say 0.5, you can see that the graph of y equal x squared is compressed along the y-axis or stretched horizontally. A becomes a negative number. You can see that it's reflected upon the x-axis, and still the graph of the base function is going to be compressed vertically or stretched horizontally until a value which is less than -1. When it becomes less than -1, something like -1.4, or let's say -2, you see that the graph is stretched vertically or compressed horizontally, but still it's flipped or reflected upon the x-axis. So let's go back to a value of 1, and you can see that the graph is right on top of the base function. Now let's talk about the parameter h. If I increase the value of h in the positive direction, you can see that the graph is going to move to the right. If I move it so that it becomes negative, you can see that the graph moves to the left. This means that h corresponds to horizontal translation. When h is positive, the graph goes to the right h units. Look, h is 2, and the graph, the vertex is here. Now it has moved to 2. So h represents the horizontal translation. When it's positive, it moves to the right, and when it's negative, it moves to the left. Now let's summarize what we have covered so far. For any quadratic equation of the form y is equal to a times x minus h squared, the value of a represents the orientation and stretch or compression of the base function y equal x squared vertically. If a is greater than 0, then the parabola opens upward like this. When a is negative, the parabola opens downward. Now, if the value of a is between 1 and -1, then the parabola is going to be vertically compressed, obviously relative to the base function y is equal to x squared. If the value of a is either greater than 1 or less than -1, the parabola is going to be vertically stretched relative to the base function y equal x squared. The new parameter that we just examined was h, which determines the horizontal translation of the parabola. If h is greater than 0, the parabola is going to move h units to the right, and if h is less than 0, the parabola is going to move h units to the left. And the coordinate of the vertex is always going to be at h, comma 0. The first question says, describe the transformation that would be applied to the base function y equal x squared to obtain the graph of y equal to negative 0.1 x minus 6 squared. Okay, the transformation. First, the a value is negative 0.1 and h is 6. Remember, the formula is x minus h, and this is x minus 6, so h is 6, remember. This means that because of the negative for a, the base function, the graph of base function is going to be reflected upon the x-axis, and because the a value is between 1 and negative 1 is going to be compressed vertically. And because h is 6, then it means the parabola, the base function, is going to move 6 units to the right. So that's about the transformations. Now we are supposed to find the vertex, identify the vertex. So the vertex is going to be, if you look at the equation y equal negative 0.1 x minus 6 squared, h is 6, so the x coordinate of the vertex is 6, and k is 0, so the y coordinate is going to be 0. So far, we found the following values, x and y. When x is 6, y is 0. This is our vertex, which I denoted by v. Now we are going to find the y-intercept. To find the y-intercept, let x equal to be 0. So the y-intercept is going to be negative 0.1 times, if x is 0, 0 minus 6 is negative 6 squared, is 36. So this is negative 3.6. So the y-intercept is going to give us 0 and negative 3.6. This is our y-intercept. Now we are going to find the x-intercept. To find the x-intercept, we set y equal to 0 and solve for x. So we say negative 0.1 x minus 6 squared is equal to 0. Since the product of negative 0.1 times the bracket is 0, this means that the bracket has to be 0. Otherwise, negative 0.1 is not 0. So I get x minus 6 squared is equal to 0. Take the square root, I get x minus 6 is equal to 0. Square root of 0 is 0. So x is equal to 6. So this means that my x-intercepts are the same as the vertex, and it's going to be only one x-intercept. As I said before in the previous videos, to plot a parabola, we need at least 3 points. Right now we have only 2 points. So what I'm going to do is that I'm going to pick a couple of points here, randomly. The first point I'm going to pick is x equal to 1. So when x is equal to 1, I have to find y. So I'm going to say y is in negative 0.1, 1 minus 6 squared. 1 minus 6 is 5 squared is 25. 25 times negative 0.5 is going to give me negative 2.5. Negative 2.5. Now to pick the second point, I have to explain something here.
Let's draw the coordinate system. I know that the A is negative here, so the parabola opens downward, and the vertex is at 6 and 0. So if this is 6, 6 and 0 is this point, so my parabola looks something like this one. Now, the first point that I picked was x equal to 1, somewhere around here. This is the point I picked. The obvious choice, okay, I can pick any point around here, but this is going to give me the orientation of the parabola for this part only. But I need a point on this side. To do that one, the easiest way of doing it is that the first point was 5. So the difference between this point and the vertex is 5 units. So I'm going to add 5 to the x-coordinate of the vertex to get the second point, which is here. So 5 plus 6 is 11. So I'm going to pick point 11 here. You can pick any point you want, but you better pick the points which are going to be on both sides of the line that goes through the vertex. By the way, this line is called axis of symmetry. The parabola is symmetric about the about the line that goes through the vertex. Now let's pick the point 11. If I pick 11, then I'm going to say y value is 11. Y is equal to negative 0.1. 11 minus 6 squared. 11 minus 6 is 5. 5 squared is 25. 25 times negative 0.1 is negative 2.15, which is the same as the other one, 4.1. Now we have enough points, we can go ahead and plot the parabola. So we start with the x-intercept, the x-intercept and the vertex, which is the point 6 and 0. Point 6 and 0 is going to be this point. The next point is when x is 0, y is negative 3.6. Negative 3 is here, so negative 3.6 is somewhere around here. When x is 1, y is negative 2.5. When x is 1, negative 2.5 is going to be around here. And when x is 11, somewhere around here, 11, y is negative 2.5. So it's going to be a point around here. So our graph is going to look like this. This is our graph. In the next example, we have a picture of the base function graph of y equal x squared, which is shown here, and the graph of a transform function, which is shown here. We are supposed to find the a and h values. First of all, we know that the transform function hasn't changed the orientation, so a has to be greater than 0. But at the same time, we can see that the transform function, which is this guy, the graph, has been stretched vertically. So I can say that a is greater than 1. And also, if you look here, this represents the h value. And in this case, you can just count how many ticks you have here. 1, 2, 3, 4, 5, 6. So I can say that h is positive 6 because the graph has moved to the right 6 units. In the next example, again, the dotted one is the graph of the base function y equal x squared, and the second graph, which is this one, is the graph of the transform function. We can see that both of them, they are opening up, so this means that a value has to be positive, but at the same time we can see that the transform function, the graph has been compressed. This means that your a value has to be between 1 and 0. Now to find the h value, again count how many ticks to the left is the vertex. This is here, this is the vertex, so it means there are 2 ticks, so this means that h is -2 because it has been moved left 2 units. The next example, again, this is the base function y equal x squared. This is the transformed function. First of all, you can see that the base function, the graph, has been compressed vertically. So a has to be between 1 and -1, but since the transformed function, the graph is a flip of the base function, then it means that the a value has to be between 0 and -1. Now to find the h value, again I'm going to count how many ticks I have. I have 1, 2, 3, and 4. So this means that h is 4 because the base function has been moved 4 units to the right.